Hello everyone, this is editorial video for problem equal LIS of CodeChef starters 22. Let's quickly see the problem statement. In problem statement, we are given a permutation P of length n and, and we define LP as the length of longest increasing subsequence in P. And then we are given that PR is the reverse of permutation P. After that, we have to print a permutation P of length n such that LP is equals to L and L of reverse of P. Means we have to print such a permutation that the length of longest increasing subsequence in P is equals to length of longest increasing subsequence in reverse of P. Let's see some examples to understand it better. In the example, we are given the n. So in example 1, we are given n as 2. So we are having 1, 2 and 2, 1. These two are the possible permutations and these are reverse of each other. In this, we can see that longest increasing subsequence is 1, 2. So it is of length 2. And in this, we can take either of 1 or 2 as a longest increasing subsequence. So we can get the maximum length as 1 only. Either we can take this 1 or we can take a 2. So 1 is not equals to 2. So we cannot get any permutation of length 2 which is having 1, 2 only such that the length of longest increasing subsequence in its reverse form is also same. Now let's see the test case 2. In this we are having n as 3. So we can form this permutation. In this permutation we can take 1, 3 or we can take 1, 2 as a longest increasing subsequence. So we get length of 2 here as the length of longest increasing subsequence, and here also we can see that this will be 2, 3, 1. Here also we can see that we can pair this 2 with 3. So we will get 2, 3. So here also we can get longest increasing subsequence length as 2. So we have to form a permutation like this. Now how to form this permutation? For this we can we can just we can just generate all the permutations and see if its reverse is also giving the same LIS. After analyzing some test cases like this, I have generated all the permutations which are having their reverse having the same length of longest increasing subsequence. Then there is something which we can notice. We can notice that the first permutation we are getting in each of them is having some pattern. Like we can see that this 4 and 3 is decreasing, this 2, 1 is decreasing, then this 5, 4, 3 is decreasing, then this 2 is decreasing, then this 1 is decreasing. Similarly for this 9 we can see that 9 and 7 is decreasing, 6, 5, 4 is decreasing, 3, 2 is decreasing. Then there we can notice that if we are having a number n and we want to form permutation of length n, then if we take the length of longest increasing subsequence as the round up value of square root n, as the round up value of square root n. Let's say this is the length of LIS. Let's say this is the length of LIS we want. Then what we can do is we can form pattern like this. Now how will this pattern will help? Let's say we take for this 8. In this 8 we can see that the longest common subsequence we can form is something like this. We can take 1 from here and then we can take any of 5, 4 or 3 from this, and we can take any of 876 from this. We can see that if we are taking a 3, then we cannot take this 5 or 4 from, let's say these are the three groups we are forming. As square root of 8 is equals to 2 point something, so we are getting round up value as 3. So we have to form three groups. Now now if we will form groups like this in decreasing, each group is having a decreasing order, and if we are having and if we are on this group, then the values in the groups in left will be less than the values of the elements in present group. Now we can see that we can take any one value from each group, and it will form a LIS. So we will get LIS of length 3. And now if we will reverse it, then we will get something like this: 6, 7, 8, 3, 4, 5, 1, 2. Here we can see we can take this 6, 7, 8 and form a LIS. We cannot extend it further because all the elements here are less than any of the elements which are present here. Similarly, we can form LIS here, like we can take this 3, 4 and 5 and form a LIS. After it, we cannot increase it further because these elements are smaller than it. Now Now we can notice that we can form LIS only of the length of group. So this gives us the formula that there will be square root n, let there will be x length of groups, and we want our LIS to be equals to x. Now this group size is giving, now the max group size is giving us the length of LIS. Similarly, when we are reversing this, then the number of groups we are having is also x. So we get this formula of square root n from here, as x into x must be equals to n. Now after that, we can to simplify it further. Let's say we want to find for 10. If n equals to 10, then square root of n will be 3 point something, and after rounding up it we will get 4. So we have to form four groups. We can take last group. We only need one group to give us the LIS. So we can take 10, 9, 8, 7 in one group. So after reversing it, we will get something like this: 7, 8, 9, 10, 5, 6, 3, 4, 1, 2. Here we can see that this group will give us LIS value of 4, and we cannot increase it further because these groups will be making LIS of 2 only. Now, and in this we can choose any of 1 and 2, then we can choose any of 3 and 4, then we can choose any of 6 and 5, and we can choose any of 10, 9, 8 and 7. This will also give us LIS of length 4. So what we have done is, firstly we have taken four elements and form a group, and after that we have the divided the rest of the elements in three groups. So these are the number of groups left, and we have to arrange them in similar fashion, like in decreasing fashion. This will be the pattern we have to follow. Now let's implement it. This is the case we are handling separately. After that, this value is the round up value of square root n. So we are finding the round up value of square root n. After that, this vector a is for storing answer, which will be a permutation. permutation of length n. After that we are forming first group. Actually we are storing it in reverse form, like we are doing something like this. Firstly we are taking 7, 8, 9 and 10. After that we are doing 5, 6, 4, 3, 2, 1. So after forming first group, this is the n minus 12 plus 1. Like if n is 10, then we are doing 10 minus 4 plus 1. So we are starting from 7 to 10. These values I have taken. After that start will become 6. If n is 10, so start will become 6. After that we know that there are n minus value left to be inserted in A. And we also know that we have to form well minus 1 groups, because one group we have already formed here and well minus 1 groups are left. So in each is telling this is the minimum, this is the at least in each elements we will be getting in the left a well minus 1 groups. After it we are taking the remainder. this is kind this is just telling the extra elements we can get. Let's say instead of 10 there is 11, then the extra element left were 6, and we have to divide them in three groups. But if n is 11, then there will be 7 elements left and we have to divide them in three groups. So we can divide them 2 equally, but we will be left with one remainder. So we can increase the number of elements from 2 to 3 in one of the group. So this extra will be telling number of groups that will be having in each plus one elements. After that we are decreasing the value of well by 1, so that we can make the so that we can do the computation for well minus 1 groups. After that, this is the simple thing we are taking, this is the difference, and if there is a value of extra left, then we are increasing this difference by 1 and decreasing the value of extra. After it we are doing this again, simple thing, again same thing. We run this n minus 12 plus 1, so we are doing start minus difference plus 1 till start, and we are pushing the value in array, and then we are decreasing start by difference, so that from 10 we can get to 6, and then from 6 we can get to this 4, and from 4 we can get to 2. So this is the thing we have done. After that we are printing yes, because the answer will always exist for for value of n greater than 2, which we can see from this, and we can also prove this. So that's the solution. Thanks for watching.